Hi to everyone, my name is Abel Sepúlveda. I'm a PhD student from the Tallinn University of Technology, and I'm going to talk to you today about our multi-objective optimization workflow based on solar access and solar radiation for the design of the building envelope in cold climates. One of the main functions to take into account in the early stages is the solar access, and two main questions could appear in our minds. First of all is, how is my new building affecting to the surrounding buildings? And how are these surrounding buildings affecting to my new building? In order to solve these questions, we have to make it clear two concepts. The solar envelope, which is the maximum buildable volume that ensures the solar access fulfillment by the surrounding buildings. On the other hand, the solar collection surface gives us an idea about the minimum height above you can locate the windows of the new buildings in order to fulfill the solar access requirement. The first step in our proposed workflow is based on the solar envelope generation, taking into account different criteria. Why I'm talking about this? Well, for example, in Estonia, there is a standard that is giving the recommendation of a minimum number of sun hours per day during an analysis period, for example, 4 months. The thing is, the Estonian standard is only giving requirements about the quantity of the sunlight, not the quality of this direct sunlight. So we thought that we can take advantage of this in order to optimize the design of the building envelope somehow. So for example, you can see two examples of solar envelope taking into account different criteria. For example, the first one is prioritizing the sun vectors with higher solar altitude, and the figure below is related with the criteria that prioritizes the higher incident solar radiation first. Once we have generated the solar envelopes and we have to decide which floor plan we are going to use and the number of different orientations for this floor plan. Once we have created the new building volume, just extruding the floor plan with the solar envelope, we can generate the windows of the new building. So now we have a basic model of the new building. Once we have generated the building volumes and the windows, it's the time to make a sun hours and radiation analysis of our new building in order to calculate different building performance indicators, which are based on the three objectives that we consider in this workflow. The first objective is to maximize the volume ratio. The second one is to maximize the percentile of the facade that fulfill the solar access requirements. And the third one is to minimize the mean incident solar radiation in order to minimize possible risk of overheating. These building performance indicators are introduced in an evaluation formula which is based on different weight factors. And the values of these weight factors depend on subjective criteria chosen by the architect or by the designer. In this case, for example, if I will go 100% to the volume, I will propose the criteria number 1 or the criteria number 4, which is a trade-off between 50-50 volume on solar access, for example. The optimal design obviously depends on the criteria chosen. So as you can see here, the different optimal solutions depending on different criteria. The bars are representing the fulfillment of each of the objectives mentioned before, and the three numbers above each figure are representing the building performance indicators. You can see easily that the combination A, the solar access ratio is really low, around 60% of the facade is fulfilling the solar access requirements. On the other hand, the volume ratio is too low in solutions B and E. But anyway, the good trade-off performance between volume and solar access ratio is represented by the solution C or D. Actually, the volume ratio is 23%, and the solar access, the percentage of the facade that fulfills the solar access requirement, it's higher than 84% actually. In the case of mean incident solar radiation, there is not so much difference between the values, so we can consider that maybe for early stages it's more important the volume and the solar access. So we have presented a flexible design workflow to be used in early stages, highly recommended when the solar regulations are really strict, typically in cold climates. Actually, the use of different solar envelopes helps to optimize the envelope of the new building regarding multiple objectives. Actually, the use of different criteria based on weight factors and a simple evaluation formula is a fast and a useful way to compare different design solutions. As future steps, I will recommend to use the output of this workflow for the design of the interior layout of the new building, but not only considering solar access requirements, but also another functions regarding visual comfort and energy performance. We can make the optimization system bigger, adding different floor plan typologies, and also the implementation of this workflow as a Grasshopper plugin for rhinoceros. Thank you for your attention.